So for homework 7, we were to create a FSM that can go through a number of states and tie them together, tie the FSM together with a register and a counter. So here I've created a register. So my register can rotate left or shift left. And as far as my data out, that is reference to the 4-bit value. And so for the architecture behavior of my register, I have if clear is equal to 1, which clear is almost like reset. So if the value resets, then the value is gonna equal to 0. And when the clock is on and it's on the rising edge, if I have a select 1 1, I'm gonna load the value. If I have a 0 1, I'm gonna shift left. And if I have a 1 0, I'm going to rotate left. So for my counter, okay. I have a 4-bit counter that will increment by 1 or 2. So here in my inputs, I have a direct, which is like a selection, a clock, a reset, and then a count for my 4-bit value. So for the architecture of my behavior, if reset is equal to 1, then temp will equal 0. My clock is 1 and it's on the rising edge. If the direction is 0, then the value will increment by 1. And otherwise, if direction is 1, then it's going to increment by 2. And then it's going to update its value. So here I have a FSM, which is controlled by the clock and the reset. So I have a process for my clock and my reset. If reset is equal to 1, it's going to go to state 0. My clock is on and my clock is equal to 1, then current state is going to go to the next state. So for example, if I'm in state 0, I'm going to reset the counter. If I'm in state 3, I'm going to increment the counter. And I have up to 7 states. So when I get back to state 7, I'm going to go back to state 0. Here I have a top level for my FSM where I tie all the entities together, my FSM, my counter, and my register. And then I assign the inputs and outputs to its corresponding component. And then here I have my test bench. Where I have my signals, my component from my top level, And then I create a loop for my counter. So to give an example of a scenario of my FSM, in state 0, we're going to reset the counter, we're going to reset the register. Everything will start at 0. And as you can see here, I'm incrementing by 1. And in my loop, I have it created to where I have every 4 values is located in a state. So here in state 0, I have 0, 1, 2, and 3. So here in state 1, we have the values 6, 7, 8, and 9. Here my counter is going to increment by 2. Down here is incrementing by 1. So here you can see 0, 2, 4, 6, 8 as it's going through the states. Here I'm shifting my value left. So if you shift left, the highest bit is going to rotate to the back, and it's going to be filled with the value. So I didn't specify what value it would be filled with. So here's shift left 110, and that's my fill value. Here I'm going to rotate left in this state. So here, when you rotate left, as stated before, this value gets shifted to the back. So here I have 1100. I'm going to rotate again. And my highest bit is going to rotate to the back, so I'm going to get 1001. And as stated before, the count is incrementing by 2. Counted is incrementing by 1. And in my DL, I have my different functionalities from my register, like my shift and my rotate. And then it resets and starts back at 0 and goes back through the states. And this is how I created my FSM and tied it with my register and counter from a homework 7.